Okay, this will probably be the last video on the lenses chapter unless I happen to forget something and make a short one to finish it up. So today it's going to be about concave lenses. These are the lenses where they are thinner in the middle than they are on the edges, and when the light rays go through them, they cause the light to diverge. So let's look at this drawing here of the concave lens. Now, these are very similar to the convex lenses in that they both have focal points on both sides of the lens, and when we go to draw them, it starts out very similar. Okay, ray 1, as it's always been, starts out parallel, and then as it hits the lens, instead of bending through the focal point, it bends at an angle as though it's coming from that focal point because it's diverging or spreading out. Okay, and then we will extend its sightline back to that focal point. Now, ray 2, we want to take ray 2 and we aim for the focal point on the opposite side of the lens, and when it hits our lens, it will come out parallel to the principal axis. Okay? When we extend this back, we end up getting where they cross a virtual image because it's on the same side as the object. It is upright and it is smaller. And in any case, wherever we put this object, we will get this exact same scenario. Smaller, upright, and virtual. The size of it will just vary as you move forward and backwards. In terms of the closer you get, the larger this will get on there. Okay, so we go through there. Once again, it is where those 2 points intersect, and this image is upright and smaller compared to the object no matter where we go. Now, one thing to highlight here is the focal length of the concave lens is negative. So if we ever do any problems, we want to say that it is a negative f on there. So if it's 24 centimeters for the focal length in a thin lens equation, we will say negative 24. Same thing also occurs with DI, or the distance image, because it's on the same side as the object. Mathematically, we will say that it is negative 20. The only thing that is positive is always the object. Okay, the object is always positive on there. Now, this was at the very beginning of the chapter, of this section, I guess, just so we can see what's going on here. Once again, if we go back to what this video is about, concave, focal length is always negative. DO will always be greater than 0, so no matter where you put it, we will always get a negative DI that is inside the focal point, and the magnification will be reduced, and we will have a virtual image. Okay, here was the convex lens. Convex lens always has a positive focal length, and then depending on the scenario, you can get 3 different situations. If we're inside of the focal point, which is this, we will get a negative image distance. It'll be larger and virtual. And if we are outside of twice the focal point, it will be reduced but inverted, upside down, and real. But if we're between the focal point and twice the focal point, it will be considered enlarged, upside down, and real. Okay, so let's do one problem here dealing with the concave lens. So just so we can see that this is, oh, that's a bad drawing. So we can see that this is a concave lens. We have our focal points here. So if we put our object here, once this, again to see the drawing, we go parallel, and then we're going to leave at an angle from this focal point to diverge. And then our second one will be to aim for that other focal point and come out parallel. So now when we extend these back, not using ruler, not real straight lines, but we will see we have an upright and smaller image, and then it's virtual in the fact that it is on this side. Remember what virtual means. It means that you will not be able to produce this image on a screen. Okay? Alright, so now let's just make up some numbers for the math. Let's say the DO is 20. Let's say we're solving for DI, so let's say the focal length is 5, and we want to know what the DI is equal to. Okay? So using the equation, same equation, 1 over F equals 1 over DO plus 1 over DI. Now, here's the key thing. We have to make sure that we say that it is a negative 1/5 equals 1 over 20 plus 1 over DI. So 1 over DI would equal to negative 1/5 minus 1/20. And so doing the math, 1 over DI, so this is just like saying it's negative 4/20. So we would get equals to a negative 5/20. So DI would equal to negative 4.0 centimeters if we did sig figs with our unit. Okay. Once again, if you have any questions, feel free to email me, and I can help figure things out if you need it.